Welcome back to Captain of Industry, and we are back here with the penultimate episode of this series and of this game. For now, of course, I would expect that I'll be coming back to this game when there are sort of new additions in terms of new content. Then I'll definitely be coming back. But I think it's also good to sort of wrap up a series while it still has some a modicum of interest. Now, as someone mentioned in the comment section, it's all very nice to have an open server because you want to see it, but who's keeping the raccoons out? And I think that's exactly going to be the problem as a server maintenance / raccoon pest control. That's not something we luckily have to deal with. There are no wildlife on this planet. It's a very small planet. It's an island planet. Now, let's talk first about what we're going to do, because we are going to do the final products of before the rocket launch, and that will be, we have reserved some space right here. That's going to be for microchips. I will show you the simplest microchip production if you are short on teraflops. So just to get it started, and then I'll show how to expand that into a bit bigger one. And if you want to go absolutely crazy, you can do that yourself. I don't see the need for that. Now, also, we're going to look at household appliances, because we are actually going to be, or we are at this point really in trouble when it comes to our Unity. I have had to make some changes over here, and just to sort of recover some Unity here, we have to take away some of the recycling. We have to take away some of the panels, because I do want to keep a bit of maintenance in order. And before we dive into the actual designs, let me just show a few things that I made that I think are actually really good additions. Since I'm relying so heavily on recycled, or at least until I cut down the recycling part, then you can see I have now built 2 recycling facilities. That's a lot. And unfortunately, we are only at 70%, but that's still good. Then we are sending it back here, and I'm now put it on belts. So we have the steel here, or the recycled iron going in, and that will go directly into the steel. And also similarly here for the copper will go into the copper, because I was just seeing that I spent like 5 trucks a month just trying to keep up with the recycled, bring it recycled, and it's something that's consistent, and you only need to bring it one place. So at some point I would recommend getting it in here. That's the iron scrap, and the copper scrap gets used a lot. You can see here there's a nice mixture of the scrap and the crushed part, and I will try to keep our stockpile of copper in check. Similarly up here for our steel. Steel is something you're going to need a stupendous amount of in the late game, so I had to do this. I've made a little addition over here that I'm not super proud of. It's working really well when you get the exhaust scrubber, so you can then get exhaust into carbon dioxide, and then you can actually take the carbon dioxide in here and turn it into graphite. That means that we also previously had issues with sulfur, because we could not get enough sulfur for our gold production. That has been solved, so now we're actually burning sulfur. I hate that, but we kind of have to. Well, we don't. We could also just transform that into just slag, but we'll keep it like this. We have a massive amount of graphite available, which is a product we need for silica, right? Silica over here. Now we can then bring the graphite in here for the silica production, and that should be all good for that. Isn't silica also used for our nuclear power plant? I cannot remember that. It just feels like it's something. No, it's not. So our base is working really well. We are just keeping up on our fertilizer. That's very nice. So let's get into the meat and potatoes of this build. Let's see. Okay, that's not a problem. And that is going to be this. We're going to start with the circuit build. Now, circuits. No, not circuits. Microchips. Microchip machine is like this. And this is where things get... Oh, actually, we're going to build it somewhere else. We're going to build it maybe here. This does not really seem to pan out anyway. So we're going to build a microchip factory here. And then we're just going to go, okay, how do I make those damn microchips? Well, there's a lot of crap here. Oh, I just need gold plus then something called a stage B thing. Okay, well, well, a stage 4B thing? Where do we have a stage 4B? That's the one. So what do we need for that? Some plastic and copper. All right, and a 4A. Okay, then we just need a 4A. That's here. Okay, nice. But that needs water and acid. Okay, I can't just keep doing it like this. I'm gonna think I'll have to do something like this part here. All right, well, that's okay. So if this is 4A inbound and that's coming 3C outbound, Oh, shoot. Don't do that. This all has to be paused. Oh, good thing. For some reason, it doesn't always remember that I want to work in pause mode. And then we have to say that was a 3C. That's a 3C. That also requires gold. Okay, well, that's at least something. And then we continue like this. So this is the complete setup. It goes like this, and it needs a silicon crystallizer, which also takes 4 teraflops. It produces 6 wafers per second, and then it goes into step 1, which requires acid and water. Step 1B, copper and plastic. 1C, gold, additional gold. That gets to output of 1C. 1C goes in here and becomes 2A, and then again acid water. So we see acid water, acid water, acid water, acid water. Here we have plastic copper, plastic copper, plastic copper, plastic copper. And here we have gold plus gold plus gold plus gold. All right, well, that can actually be simplified. What if we did something like down here and then said, you know what, this one's going to do all of the A parts, 2A and 3A and come on. God, there, 4A. Yes, so this is going to do all the A parts, so that's all of that. This is going to do all the B parts. It's much easier to look for just anything that has copper in it. There, right? And this one will do all of the C parts. C there, and here, and here. So now we've sort of redone it into here. That means what I need to do is basically make a string that goes all the way through and then loops back and then goes through again and again. At some point, we'll exit that loop. We could also make it even simpler for the very first iteration and then simply go, you know what, I'm just going to build everything in one and then just loop it around. Because when you want to get started on this, maybe you don't have this UI is not designed for clicking everything. That's fine. We'll click all of them and there. So you can also build one and then have it completely recycle all the time. And I think that's a good idea. You basically have 3 steps, this, and this. This one will go through 3 wafers per minute, which is super annoying because this produces twice as much. And then it'll output 6 microchips. So all of this will be 6 microchips. All of this will be 6 microchips divided by 4. So that'll be 1.5 microchips per minute. And this one will be absolutely nothing, but it'll be something, right? And as you progress, this might be okay. So what I want to propose is we build a design that is catering for this, but starts as this. That's going to be our objective. So let's go back here and try to design it in place because that's always more fun. The first thing we want to do is the crystal silicon nicer thing here. Let's have a look at it like that. I don't know exactly where that's going to be. And what do we need inbound for this? We are going to need some silicon, and we're going to need some water inbound. So water is also going to be needed for the first step, so that's not going to be something we want to take in here. I'll be doing very, very, very small quantities because there is no reason to build higher quantities. I'm going to leave in one aside, and then it's very important that I have 1, 2, 3, 4. That's actually not important for this, but it's important for the next part. So I'm going to get some water in. We'll get some water. This water will be... I don't know. We'll build it here. We can move these as we go forward. Now, what comes out here is going to be silicon wafer. I'm actually going to take this out and then flip it, because that makes it closer, and then go back here to our microchips. So I want to make sure that I have a design that works for 1 microchip and for 3 microchips. So let's have a look at it like 1, 2, 3. And as I look at it, this is the distance here, and 1, 2, 3. So I need to move it one further back. I might even want to move it one more further back. Right. I'll build it like this. I'll build it like this. Yes, that's going to be fine. All right. So what I need to do is, at this point, this one will put wafers out. And if the wafers are coming out, then let's get them here. Wafers go in, and then it completes in here. And actually here already I want to have as short distances as possible. So that's already dictating some of the things. Let's get you closer as well here. That one. And you're going to get water. Nope, that has to be here. So that water goes in, and then I get the water on this side. That one. And the first one will take care of all of the A's. That's at least the intention. Or actually, this will be the final build. So let's do that thing for now, because we're going to build it as simple as possible. This one will be... Oh, hold on. I'm going to have to copy it from the one that already exists. This one has everything. And go back into... Because that's annoying to do that. This will do everything. Here's another problem. It has to do everything in the right sequence. So you need to be able to prioritize the final one. So for example, this one has to be prioritized. And there might be a little shortcoming on this UI here. How difficult it is to cycle these. But that's something we're going to do. We're going to be prioritizing these so that we have microchips, and then we have the B process, and so on all the way down. Many years later, this has been resorted, and we are ready for the next step. All right, so at this point, I want to pretend that I have one more on the next to it, so that we kind of get that idea. And what I need to do is, I don't know if it's even a good idea to try this. Okay, so I'm gonna get acid, because this one needs acid and water, the first step. That's going to need acid water, and I'm going to need to make sure that my acid is... Okay, we'll get it like this, and then hopefully it'll sort itself out. So that's acid. I'll mark it as acid here, and that means I need to get my water. My water here. Into... I guess into that one, but it actually needs to go into here, because this is the only one that we'll have. It's super complicated that I want to do 2 things. So you know what? I'll just only pretend. I'll only do the simple one, and then we'll have to figure out how that's gonna work out. There. And now I need 3 inputs. What is that? Gold, plastic, and copper. And I'm gonna need to get plastic and copper first. So I'm gonna get these things. That will be 1 for plastic, 1 for copper, 1 for gold. Or here, that's copper's first, and then plastic second. Here, and for this, I'll have gold. Now, obviously, I could just bring in the gold since next door, but I'll try to be consistent also, so that you can just copy it as you like. And then from here on, we are going to go designs here. There. That works, and that's the way we can get all of it into this location. And I'll just need a little outbound here for microchips. As it so happens, microchips, where are you at? You are here. That's the whole point. And then I'm gonna... Ah! Please don't do that. Okay, it didn't lose anything. Alright, and here I will get now a splitter. Because that needs to be right there. And this will basically say, if you encounter a microchip, then get rid of it. That's definitely not it. It's this one, flat solder. There, that's why. Microchip there. If you see a microchip, push it out on the side and send it back in. If not... Huh? Alright, what? It's rotated. There. And then it goes back and into this location. That one? Yeah, that works. And then I'm going to replace that with a long line so that we're ready to build the next part. And also we need the water to come over here. And then I'm obviously going to prioritize this cycling here. And this is of course built too big, but it's going to get the job done for now. Let's see, water, we're going to get lots of water, we're going to get lots of acid. Actually, none of these have very high quantities, so I'd much rather have built the small ones, just to really accentuate that this is all about very, very small quantities. So this will be acid. Yes, this will be water. Yep, this will be silica. The polysilica. Yep, yep. And we'll be getting some copper, we'll get some plastic, and we'll get some gold. And we'll see if this one is ever going to get built. And we'll also set warnings up on these as well. So this is kind of what we want to do. Let's get it built. And that will use 4 plus 4 teraflops of power. So that is that's still okay. And I will be setting up warnings on all of this, which means we'll be getting a lot of warnings right now, but we should be hopefully getting rid of these warnings. And as this gets built, we can start on the next design, or we could also just let it. Yeah, let's get it to stabilize. Oh, this one should not have a warning. This should just be highlighting that there's a problem. So, poly, water, acid, copper, plastic, and gold. All of these are coming in. This is getting built. All right, let's wait for it to get online. And now we have the acid coming in, and we are starting to work on just the very basic things. So what is going on? The fact is that it cannot build any of these. So it starts from the top priority-wise, and the only thing it can do is transform silicon wafers back into microchips. So that's going to take quite a while to do that. We are going to let it pass through. You can see now it works. It gets one silicon wafer out, and it goes in here. And then the microchip will siphon back here on this line and then move back in here. And there we go. So now what we are seeing on this belt is we have 6 silicon wafers and 1 microchip stage 3. And obviously it'll be working on all of these first, and it'll just suck those in. These are then cycling back. I can pause this if I want to, so that it doesn't fill up with wafers just now. I think I'd actually want to do that. Yeah, let's do that so it doesn't fill up. That's a good way to get it started. But if you only wanted to build it for 1, then there would be no reason to build all of these long lines before and after, and you would want to make it as close as possible. But we're designing it for 3 next to each other. This is just to get it started, and maybe you don't have the teraflops to make it available. In that case, if you only have 4 teraflops, you can start this one, build up a little stockpile, turn it off, build the next one, and it'll be perfectly fine. So what we're seeing now is that, let's see, it is still only making wafers because we don't have the single one of those inbound yet. They are right here. There are now 2 of these. And that means as soon as it starts pulling that in, which I hope will be, oh, it's actually right there. So now it will start working on the next because it's higher on the priority list. Come on, show me, prove me to be right. Brilliant. And then it will now just keep siphoning through here repeatedly, again and again and again. It'll be, you can then get started on something else in order for this to just build up a stockpile. It'll gradually be better and better. And as we see now, we now have a 1B coming out. That 1B will go in, and when it then gets back in here, it'll be priority, and therefore sort of gradually it'll refine the products more and more. And of course, if we enter this one so that they can keep putting things in, like that, for example, then it'll have some on this belt. It'll be a A1 first, and then a B1, and then it'll be some wafers, 6 wafers, I guess. 6 wafers? I don't know how that works. But you will be able to see here, and hopefully it'll get the 1B in soon enough, so we can see that it actually progresses to the next level, which is exactly what we want to see. There, now it has gotten one in, so we need to make sure that it goes through this cycle, and once that cycle goes in, and then we'll actually make a 1B into a 1C. The reason why that's important to see, is because then I have all of the processes working. It has the acid water, it has the copper plastic, and it has the gold one working, and also we see that the priority system is working, and then it will sort of just gradually just improve these as time goes by. What we're going to do in the meantime, while that is chugging along, is go over here and start burning through all of our resources in making household appliances. That is the next thing we want to do. Unfortunately, well, household appliances is super good, but as always, right, there's always a but, and that but is about how absolutely insane the numbers are for what it requires. And yeah, that's unfortunate, but it is what it is, so we'll have to deal with that. All right, let's have a look at this household appliance thing. Household appliance here, it'll give us a massive boost on our Unity, which we kind of need to keep things going. But 16 electronics, and this will make 16. We are almost certainly going to need more of these, so let's build 3. Even if it doesn't need 3, then it's still going to be nice there. I'll build the last level here, that one, because we have 3 inputs. And of course, as any good TV chef would do, we have already prepared the inputs out here. Here. And the last one is that one. So with these done, we should be able to start making... no, you know what? I'm not going to build that yet. We are going to get the outputs as well. Yep. And I don't think we can get under that. So let's go up here. And that will go... Are you level 2 or level 3? You're level 2. Right? No, you're not. Ah. Damn it. If this is level 3, then I need to be level 3 as well. And I get it right underneath here. 1, 2, 3. 3 here. And then that could merge in, but I don't want to. And then I go over here. There. Super important that it looks exactly the same. And I will be bringing it into... And yes, we have prepared this one in advance. It'll be using 33.5 of these per minute. That means 2 of these are not enough. That means I'm going to need more than 32 household supply, or more than 32 electronics just to keep this flowing, which is disgusting. But it will help very much so on, if we look at here, it's 2.8 we can get additional from giving a steady supply of this. And considering we are having so much issues with this, then absolutely we'd want to do that. And I'd also really like to get another level of recycling done. And I'd also like to get clean panels, but that's not important compared to everything else. We're now down to 1.5 Unity, and we have actually turned down a few of the things out here just a bit. There might also be a case for that we need to scale up this part, either by rebuilding it or by just throwing some Unity at it. I've also, up here for the steel, this is running on Unity right now. It might not need it right this moment, but as soon as we get going, then it will need it. Let's have a look at how this is faring in the meantime. Oh, hold on. Let's just see that it actually works. Yeah. Okay, so it's working here. It's working. And do we get this inbound? We do. We are now starting to work to consume some household appliances. And we are now getting... Where is it? Where is it? Here. I want to get... Okay, it's starting to get in there. That's because probably it's not the whole month. But we're starting to get some bonus Unity. And we'll be rebuilding the Unity extremely quickly as a result of this. Now, At this point, what do we have on this belt? We have a microchip A2A. So we are working on 2A. That's good. We are getting higher up. This is working. Oh, look at this one. This is 2B to 2C. So that's the one that's definitely the furthest ahead here. That'll be now a 2C. So you can see here, as soon as you have it available, then I would highly recommend replacing this with a 3 build, because if you are looking at how much this is going to be built, or how much this is producing in terms of microchips, it's going to be nothing. You're going to spend hours and hours on not really getting much in there. So we can do this. I think I will actually do... There. I'll take this one out, and the reason I'll take that out is because then we can leave this running in here and let that siphon through, and then have them all being stuck inside this one. It's actually interesting when you look at something I noticed that is brand new, which is super nice, is here. You can see how much is inside this one. Funny, I saw some that had way more than that. I guess that's because this one has 34 in it. 34, that's insane. So if they're right next to, they will have 34. If they are not right next to, like this, they will only have 4. That's interesting, right? That's super interesting. And those will disappear if you delete the connector. At least they used to. So that's something. How are we doing this? Oh, look at that one. That's a really good one. This is coming all the way up. And it's just checking. This is now a 3A. It's almost all the way through the loop. Damn. It's nice. And oh, actually we have a problem with this. Yeah, we should let this one completely run through. All right, I'll do that. I'll let it run through, and then when we have all of these, because we're gonna be wasting those later on. All right, you can either waste it, or you can accept that you need to let this run for quite a while. So I'm gonna let it run for quite a while, so that we actually get some microchips out. Once we get the microchips coming out of this one, then I will be replacing it, just sort of for good measure. And now we're coming up on the very first set of microchips. We have the 4B being converted to a microchip. Let's have a look at that coming out, and we'll just be celebrating the first 4, because it's on a 40-second cycle. What? No, 2. Ah, it's on a 20-second cycle. Look at that. It works. It does get it filtered out, and we have a magnificent amount of 4 of these. Brilliant, brilliant, brilliant. And they are now being converted. I'll be letting the rest of these run out, and then once they are running out, you can see there are only actually 2 that I'm running through here. No, 1, 2, and then 3 are being processed. Oh, there's also some other ones that are stuck a bit further down that needs to go all the way through. There's actually some all the way down here to silicon wafers. I think this is, we saw that it works all the way through, so in principle it works. It's really tempting to let this one run through, so we can just get the last one, just that last one, right? And then it works on here, and I should be able to see this one. This is a 4B, so a 4B gets to become another set of microchips. So while we are running on this, then it's a good idea maybe I can encourage you to hit the like button, subscribe to the channel, all that good stuff. And if you want to support the channel, then consider pledging on Patreon. That is how I keep this this channel free of ad activations that I so loathe, and I'm sure that you loathe as well. So that we go. That is 2 more. I will just I'll ignore these and just get started on conversion. Convert and convert. Yes. And these just need to be update. There might be a problem. Yeah, no output. I know. There and there. That goes in. That goes out. And then the question is, what do we want in the first one? Well, the first things first is I need to kill this and kill this for sure. I also need to kill this one. This is just basically for you to see how to upgrade these things. I'm gonna be doing that just to make sure we get these out of the way. So at this point now I need to get water in here, and then I can get acid in here, and I can get the gold in here. So that means anything that is acid, U in here, and then this one will only have the stuff that is water and acid based, and the priority is obviously still the same. There we go. This one will only have the stuff that is copper and plastic based. There, copper and plastic based. And this one will only... Oh, crap. Yeah, lovely. This will only have the stuff that's gold based, and I'll need to click it from the bottom. That's the way you get it in the right priority. And there. So that is microchip, 3C, 2C, 1C. And with that done, switch it on. It's all good. And you will be prioritized inbound from here. Now, I don't know if I have anything coming in. I don't think I do. So we are also going to have to rebuild this. Unfortunately, the problem we have... Oh, okay, this one has at least one thing that could be pushed on. This is likely to have something stuck here that I'll never get out. And I just don't care. Over time, this is a good investment. So we'll keep focusing on this being a good investment. So now it goes in. It works on a C stage here. It'll also be always having enough silicon wafers to get going. This is a... Oh, I didn't see it. Doesn't matter. What you will see, and I know that some people have been commenting on it like, no, it's not working. This will be stuck with the silicon wafers. And that's true. It'll be stuck. Right now, this one has more silicon wafers. But as long as we process those silicon wafers, then whatever else comes in, since the priority is here, then whatever comes out from the other ones will definitely be working. So this is pushing onto this, and this is pushing on. So that's at stage 3. So what we'll see is that this one, the 3C, it'll go in here, and yes, it has to wait a bit until I have processed enough of the intermediates to proceed. So after this, it'll go down and work on some silicon processors, and then at some point we'll get the 3C or the 3C in and make it into 2A as we consume this and send it into the next here. This is still only silicon wafers, and we haven't imported it yet because it's still stuck inside this one. You can see that they disappear in here, but they don't move on. So there is a stockpile in here. I don't know how big it is. Hopefully not 30. I know it's not 30. But it's going to take a few iterations before it actually processes through and starts consuming the next. They are just happily flowing in here. Now is the next one's going to happen now. All right, finally we have a visual here that we have the 3C coming in. And yes, that means there's going to be a lot of silicon wafers that are going to go all the way through, but it doesn't matter because over time it'll saturate. What we'll also be seeing now is that all of the stuff is not going to be silicon wafers. It's going to be the stuff in here that unfortunately I can't see, but I know it's there, will gradually be replaced by, instead of coming with silicon wafers, it's going to be replaced by the C1s going through, and then this can just, well, basically never push out anything ever again, because it'll, well, not ever, but until all of the 1Cs are going through into the next. But this is the 2A. There we have the last piece of the process here, the one that went all the way through. It's now turning into a 4B. I hope this makes sense. I think this build is very, very good for exactly what we need, and we'll be getting the first few microprocessors out here. And yes, it's going to take an absolute disgusting amount of time. This will be producing only 1.5 every minute. If I had one, it would be 1.5, or it would be 0.5 every minute, but this is 1.5 every minute. And what we'll see now is that this will not be moving for quite a while, because all we have in here, we have a bit of silicon here, but primarily we're working on these that have been cycled through a few times. Here, well, there are some silicon wafers that will be needed to be pulled in. And the thing is, these cannot be pulled in until this one gets consumed. So that means at some point, we don't have any more stockpiled of the higher ones. And then as a result, as you can see here, it pulls in the silicon wafers. Now there's more of the microchip. There's still probably some stockpile in here. It is 100% not jamming. That is, it actually pulled in here. It's never jamming this part. And that's something I think is super, super nice. And it's been working. I've been having this work for tens of hours, and it's not jamming at all, and they are perfectly synchronized. I don't think it's worthwhile to build it 4 times as big to get 4 times as much. This is a really crisp little design, and just keep it there and then start working on all the other problems in your base. Then you should not have any issues at all. Let's have a look here and confirm. Okay, we're not getting enough household appliances just yet. That's really weird. Oh, we're actually just barely able to keep up. Oh, right. Of course we're not able to keep up. Oh man, you've been already... You can delete your comment yelling at me for that. There we go. Now I get it. All right, I want to see that online. Let's get that online, and in the meantime, we can go over here and see what the levels we're up to. 2C, not impressive. There's nothing more than 1C here. That's low levels, low levels. Yeah, they're just working on low levels right now. But we do have the first bits going through. And 1.5 on average, once it has stabilized, is super nice. And, oh, look at that. That was exactly what we needed. A big boost of household appliances. Washing machines are coming in. And we now have, well, soon we should have this one at full saturation. And that's going to be where we wrap this up with microchips being built. We have our server capacity, we have household appliances, we have everything we need. And the only thing we have remaining is to launch the rocket, or build the rocket launch facility, build the launch facility, move the rocket over and launch it, which is something we're going to do in the next episode. So thank you very much for watching. I hope you are enjoying the series and want to stick with it until the very end. Until next time, take care, and as always, stay effective.